Knowing what we know about the slope and the y-intercept means that we can take just information like the slope and the y-intercept and draw a graph from it. We begin at the initial value at the y-intercept, which is 0, -4. And then I see the slope is -2/5. This negative sign can go with either the numerator or the denominator. I'll have it go with the numerator and think of this as a rise of -2 or a descend, and then 5 to the positive x direction, so 5 to the right. So I can go down 2 and to the right 5. If I don't want the negative sign in the numerator, I could move it to the denominator, and this would have a slope of a rise of +2 and a run of -5. So I move to the left. Rise of 2, run of -5, and there's our line. We can write an equation from this line and from these pieces of information because we know that any linear equation can be represented as y = mx + b. In this case, our slope is -2/5, and our y-intercept is 0, -4, meaning that our b is -4. We don't even need to graph this to figure out that equation. If we want to write the equation of a line with a slope of -2/3 and a y-intercept of 0, -27.5, we know from y = mx + b, if we can find the value of m and the value of b, we've got this made. In this case, the slope and the y-intercept are directly given to us. M is -2/3, and the y-intercept is 0, -27.5, so b is -27.5. There is our answer. We can come up with the equation of a line given a variety of information. We don't need to be given the slope and y-intercept directly. Let's consider this graph. We want to find the slope of this graph, the y-intercept of it, and then write the equation. So for the slope, I want to pick points that I'm sure of, like at 0, at 1, 0, and where's another good point? Look up here at 4, 2. So I see that I have a rise of 2 and a run of 3. So our slope is 2/3. For the y-intercept, I can't read it off directly. It's somewhere in between 0 and -1, closer to -1. So we're going to have to calculate it instead. For calculating it, I know, again, y = mx + b. And we know some pieces of information here. Every point on the line is a solution of the equation. And we also know what the slope is. So really, what we have here is I know that this equation would be true when x is 1 and y is 0 and m is 2/3. I just don't know what b is yet. So we have the y value is 0, the m is 2/3, the x is 1, plus b. Now we have an equation that we can solve for b. 0 equals 2/3 plus b, and just subtract 2/3 on both sides. There is our b value. So we know that our slope is positive 2/3. Our b value is negative 2/3, which means our y-intercept is at 0, -2/3, which we can double check on the graph. That certainly looks right. And now we can write the equation of the line. Y equals 2/3 x plus b, which is negative 2/3. One last example of writing the equation of the line is when we're looking at a table. We want to find the linear relationship represented in the table below, where hours is the input and dollars is the output. Hours being our input, meaning that's kind of our x value, and the dollar output is our y value. So again, what I want to do is I want to find the slope, and find the y-intercept. I'm going to say find b, and then write the answer. We know how to find the slope from a table. Slope is always the change in output, or change in y, divided by the change in the input, the change in x. So here I see the change between $111 and $106 means that we go down $5. That same step is repeated at every row in this table. The hours, meanwhile, are increasing by 1 each time. So our slope is the change in the y, which is -5, divided by the change in the x, which is 1. We're going to write that more simply as just m equals -5. This is another problem where we're not given the y-intercept directly. So instead, we have to calculate it. I'm going to calculate it by taking one of these data points. Let's just pick the first one of 2, 111. The x is going to be my 2, and the y is 111, and m is -5. With that information, we can plug all of that into y equals mx plus b. The x is 2, the y is 111, and the slope is -5. This turns into 111 equals -10 plus b. Add 10 on both sides. 121 equals b. Now that we have our slope and the y-coordinate of our y-intercept, we can write the linear relationship in the form of y equals mx plus b. Slope-intercept form. In this case, y equals -5x plus 121. For some of these problems, it doesn't matter what variables you use as long as you've defined them somewhere. Here we've used x and y because that's conventional, but if we wanted to say, let h equal hours and d equal dollars, we could also write this as d equals -5h plus 121. Thank you.